You start the month ready to work, but within days, you hit a wall. A system notification warns your usage limit is exhausted. When that limit runs dry, the standard response is to assume you must pay up or stop working entirely until the system resets. However, the update to Claude Opus 4.7 includes an architectural change that conserves tokens at the model's core. By combining this native efficiency with a few specific workspace configurations, the same subscription can support a significantly higher volume of complex work. Usage limits are determined by how often the model is forced to process redundant data. Reducing that redundancy creates more room for actual output. The first step addresses the invisible drain on your tokens, repeating yourself. Every time you explain your role or project background to the AI, you burn through your daily limit. In the Claude settings menu, enabling the toggles for memory and chat history search prevents this repetition. With chat history search active, Claude independently pulls up your past preferences and working styles without requiring you to retype them. For larger fixed datasets, we use document caching. You upload a reference document once into a project, and it locks into a secure cache. Subsequent prompts bypass the initial processing phase. Notice how the token cost drops to 0 on the right side. The system remembers your uploaded materials without charging you again for that same information. This cache is the designated space for your dense, high-value materials, such as API documentation, legal precedents, or detailed brand style guides. Warning tone. Pasting these same massive text blocks into every new chat window is a common error that consumes tokens unnecessarily. Inside a cached project environment, the system only charges tokens for newly added or modified information. Offloading fixed context to the system's memory preserves your daily computational power for active problem solving. With your background systems optimized, the next priority is adjusting how you actively send requests. This 3-tiered pyramid outlines a step-up strategy for model selection. Haiku sits at the wide base for quick questions, while Sonnet handles standard daily tasks in the middle. Claude Opus 4.7 stays at the peak. This model should be reserved strictly for high-level reasoning and complex multi-step logical operations. Opus 4.7 uses an adaptive thinking mechanism to scale its own processing power, dedicating brief resources to simple questions and heavy resources to complex reasoning. On the left side of the screen, you see the effect of sending rapid-fire individual questions. Each message triggers a new baseline processing fee. Consolidating related questions into a single structured message, as shown on the right, minimizes those baseline fees. Occasionally, the internal logic of Opus 4.7 might treat a crucial prompt as a simple query. These moments require a manual override. Use explicit commands to trigger deep thought, such as list all considered possibilities or provide a complete logical argument. Securing a highly detailed and accurate response on the first try eliminates the need for expensive follow-up questions. Getting a complex task right immediately is more efficient than paying for multiple attempts to correct a vague answer. Every time you send a message in a thread, the model rereads the entire conversation history above it. This is the rereading tax. Keeping a single thread alive long after the topic has changed forces the system to process massive amounts of irrelevant historical data, which quickly drains your usage meter. Direct, commanding tone. Open a new chat the moment a specific task is resolved. Starting fresh cuts the context burden back to the baseline minimum, instantly saving resources. With projects and memory active, a new window does not mean losing vital background context. The system still recognizes your role and requirements. Thread management is about controlling the volume of data the AI is forced to carry into every interaction. One final variable is global server load. This map displays a low traffic period during the US nighttime, which corresponds to daytime in Taiwan. Executing your heaviest computing tasks between 5 a.m. and 4 p.m. Taiwan time ensures higher fluidity and fewer interrupted responses. To recap the standard operating procedure, first, activate memory, cache documents in projects, use the step-up model, consolidate your prompts, and keep threads short. These combined actions allow a Pro or Max subscription to handle double or triple the interaction capacity of a standard setup. When you control these variables, your usage limits shift from a constraint into a concentrated beam of computational power. Applying these methods focuses Claude Opus 4.7's processing power exactly where it is needed, ensuring every token spent contributes directly to the final result.